Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we dive into Stanford's groundbreaking eSkin, a soft, flexible innovation that restores the sensation of touch for amputees, transmitting signals straight to the brain and blurring the boundary between human biology and technology. The human skin contains mechanoreceptors that can sense something as delicate as the weight of a butterfly, or heat or cold from a nearby object. It can also detect the delicate rhythm of a loved one's heartbeat, and whether the hand raised at us is raised in a fist of aggression or a peace sign. But for people with prosthetic limbs, these sensations, good or bad, are something they miss. Now, researchers have found a way that can help restore these sensations for amputees through electronic skin. Stanford University's BOW research group has developed a soft, flexible electronic skin that can mimic the process that causes a finger or a toe to react and move away when poked, or when they touch a hot surface. This current eSkin really has all the attributes that we have been dreaming about, says chemical engineer Zhenan Bao of Stanford University. This technology, as per nature, could lead to the development of a covering for prosthetic limbs. The best part about this breakthrough soft eSkin is that it can directly transmit electrical signals to the wearer's brain to allow them to feel pressure, strain, or changes in temperature. Unlike previous attempts, this new eSkin uses soft integrated circuits to convert sensory information, such as pressure and temperature, into electrical signals similar to nerve impulses. The goal is to use this technology in prosthetic limbs to provide sensory feedback and improve control for amputees. In an experiment, the newly developed electronic skin was tested on a rat. The eSkin was connected to the rat's somatosensory cortex, which is the region of the brain involved in processing physical sensations. When the electronic skin was stimulated by touch, it generated an electrical signal that was transmitted to the brain. From there, the signal passed through an artificial synapse to the rat's sciatic nerve located in its leg, resulting in a twitching motion of the limb. Bao says that in the future, they hope to develop a less invasive system that won't have to be implanted into the brain. We envision that for people who lost their limbs, we don't have to implant it into the brain, she said, as per nature. We could have an implant in the peripheral nervous system. The current version of the eSkin has to be wired to an external power source, but the researchers hope to ultimately develop a wireless device. This new eSkin runs on just 5 volts and can detect stimuli similar to real skin, described Weishan Wang, a doctoral candidate in Bao's lab, the first author of the paper. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.